Bismillah. We are going to study about the definite integrals today. Okay. Before this, what was happening that when you were integrating something, for example, you have x plus 2, for instance. I'm just taking a very simple example. So when you integrated this, you got x square over 2 plus 2x plus c. Now, this is a typical example of an indefinite integral, okay, because the c is not known here. Now, what is a definite integral? When you have a definite integral, you will have the limits to be applied to that integral. Like, for example, if you have a limit from 1 to 5 of the same x plus 2 dx, okay? So this will be limits from 1 to 2. This is x square over 2 plus 2x. And this time you will not be required to write this plus c. I'll tell you later that why don't we need to uh, apply this, write this plus c over here. First, you look at the rule. The rule is that if you have to find limit from a to b, the integral of f of x dx. Suppose by integrating you get capital F of x, just to keep a different name here. And this is limit from a to b. So this becomes f of b minus f of a. And that will be, a numerical value over here, f of p minus f of a. Like if you have, if you see here, when you integrate this, so first of all, you will be, if this is your f of x, so you will find f of 2, that would be 2 square over 2, then plus 2 into 2. And then your f of 1 would be like this. This is 1 square over 2 plus 2 into 1. There is your f of 2. This is your f of 1. So this would be, if you simplify this, you get this as 2 plus 4, that is 6, and minus half plus 2, that is 5 by 2 or 2.5. So that is this 3.5 is the value of this definite integral. You see that you're getting this integral as a numerical value over here, as a numerical value over here. So whenever you are given the limits to be applied onto an integral, so that integral is called a definite integral, because now you have a confirm a definite value of that integral. Okay, now let me uh, take you back to the book here. If you look at all these questions here, but you can see that you have to apply the limits onto them. Okay, now just one. Let me just create some space here so that I can do the working right here rather than going back to that board. Okay, uh, I will be telling you now that why don't we need to uh, put that plus c into our integral. Look at this 1a. This is limit from 1 to 2. This is 3x square dx. So when you write these limits, you either write both the limits to the right side of this integral sign, or you do it the way I am doing, one at the bottom, one at the top. Never write both of them towards the left over here, okay? Examiner might cut a mark for this if you write it like this, 1 to 2. Don't write it like this, okay? So you can write it the way I am writing it, 1 to 2, or the way the book has shown here. Acha bachcho, now when you integrate this, you get, the moment you integrate, you must use the square brackets here. Now this is not the integral sign, so, and this is a bigger bracket here, so you can put them like this now. Okay, so this is 3x cube over 3. And for example, you want to write this plus c. See what will happen with this c now. This is limit from 1 to 2, x cube plus c. You know that this 1 and 2 have to be substituted as x over here. And when you do that, this would be 2 cube plus c, and then minus 1 cube plus c. And this c will be eventually cancelled out. This is 8 plus c. minus 1 minus c. So there is no need to write the c. First reason is that you are dealing with the definite integrals. Secondly, this is going to be cancelled out. So this is your 7 over here. From now on onwards, I will not be writing this plus c. Okay. Okay, now let's try this p part. This is limit from 1 to 3. And let me write it as 4x to the power minus. Remember all those techniques of integration. Okay. So this is 1 to 3. You can write this for inside or outside. That makes no difference. And nevertheless, there's just one term over here. So this is x is to power minus 2 over minus 2. And we don't need to write plus c. Remember, writing plus c is equally important when you're dealing with the indefinite integral, and especially when you have to find the equation of the curve. There, you lose more than half the marks if you don't write that plus c. But here, this is not required. Okay. So this is, you can even take this minus 2 out if you want. Anyhow, this is 4 into, um, this is minus 1 over 2x squared. And these limits, after it has been integrated, can be written on the right side as well of these brackets. So I'm just writing this to show you that you can write these limits. Sometimes you're managing the space, so you need to write them to the left or to the right. Okay. So this is going to be 4 into minus 1 over 2 into 9 is, so let me write it as 2 into 9 minus 1 over 2 into 1. So telling you again, the formula for this is that if you have limit from a to b, this is f of x dx, and you have integrated it, and this becomes f of x. So this is going to be f of b minus f of a. You put the upper limit first, then minus the lower limit. As I have done it here, I first of all substituted this 3 into this x here, and then there's a minus sign, and then I put that 1 into this limit here, this integral here. So this is 4 into, this is 4 into um, minus 1 over 18, and then plus 1 over 2. That is 4 into, you take the LCM, you use a calculator. This is 18. This is minus 1 plus 9. That is 8 over 18. So you can simplify this. Uh, for 2 fours are, 2 nines are. This is 16 over 9, or 1 whole 7 over 9. So that is the integral. This definite integral is equal to this 1 whole 7 over 9 over here. ठीक है?
सर हम
हम्म
शुरू में 2 से डिवाइड नहीं कर सकते थे
शुरू में बिल्कुल कर सकते थे. You could
ये
do that. You could do that better.
ओके
You could
ओके
do that. Yes. Okay. Now let's try one more question. Okay, maybe apart from question number 2. You see, this will keep on varying the different uh, situations where you have to use simplify these expressions before you integrate it. Let me try this question number 2. Which part I should try? Question number 2 is which part? Tell me quickly. Hmm. A, B, C, D, E, F. Which one?
ई सर
E. Okay. This is 2E. So this is integral from 1 to 2. Let me simplify it here. This is 3 minus x into, you can save your time, like you can avoid writing all these integration signs again and again by simplifying this on a side, showing this to your examiner. Okay, this is 24 plus 3x minus 8x minus x squared over x is per 4. This is 24 minus 5x minus x squared over x is per 4 over x is per 4 over x is per 4. So I can write it here, 24x raised to power minus 4 minus 5x raised to power minus 3 and minus x raised to power minus 2. This is the form that we should have to integrate. Okay? And by the way, these are all first technique situations here. So this is limit from 1 to 2. This is going to be 24 x raised to power minus 3 over minus 3 minus 5x raised to power minus 2 over minus 2 minus x raised to power minus 1 over minus 1. And I'm not writing a plus c, you can see that. Acha, you see that here you might overlap these limits. So I'll be writing the limits to the right this time. This one is going to be minus 8 over x cube. This one is going to be plus 5 over 2x squared. This one is going to be plus 1 over x. Try to have the positive powers on x before you go on to apply the limits. I'll be writing the limits to the right this time because there was a chance of getting overlap here. Acha ji. Then we have, um, so this is going to be, now let's put the limits here. This is uh, minus 8 over 8. 2 cube is 8 plus 5 over 8. 2 into 4 is 8 plus 1 over 2 and then minus. When you put 1, this is simply minus 8 plus 5 over 2 and then plus 1. You can use your calculator if you want here, okay? This is minus 8 plus 5 is minus 3 plus 4 is 1. This one is 1 over 8 and you have here minus 7 minus 14 minus 9 over 2 plus 9 over 2. You can please keep checking. I might make a mistake here. The LCM is again going to be 8. This is 1 plus 36, that is 37 over 8. This is 4 whole 5 over 8. So I might have made a mistake here, but this is how you have to do it. So this 4 whole 5 over 8 is the numerical value of this, all of this definite integral over here. Okay? Now you should try these parts from, you can start from question number 1, okay? And I would suggest you do all the parts of question number 1, 2, and 3 just to be really good at this definite integration.